can also look into the points. So what is the operating system? What is operating system? You can tell. What is operating system? It is a software or interface
between hardware and software.
Interface between hardware and
Software.
Software means the user versus hardware. Correct? This is user. This is the interface which presents between user and the hardware. Additionally, we can tell operating system is a resource manager. Correct? So coming to the resource manager, what are the types of resources are there in our computer? What are the types of resources are there in our computer?
RAM.
First one is CPU. RAM means our main memory.
Secondary memory.
Secondary memory. And what are the resources? Input output device. Input output devices. So these are some of the resources that our operating system usually manages. Another thing we can tell, like it provides the platform for the user. Platform for users. Correct? So that means operating system is nothing but the interface which is present between user and hardware. It provides resources. It manages resources. There are various types of resources are there: CPU, memory, input-output device, or secondary memory. These are few of them. Additionally, it provides the platform for users to access the operating system. So, for example, at the lower level, we have hardware. On top of that, what do we have?
Kernel.
Operating system. Very good. On top of that,
Applications.
user applications. Very good. And finally,
User.
users. So the main objective of the operating system is to provide services. Correct? Is to provide services using or in terms of or while supporting the applications for users. So up to this much is clear. What is operating system and how it functions? Okay, it is an interface between the application, which is nothing but the user and the hardware. Okay, hardware. Now coming to the goals. What are the goals are there for operating system? What user actually want and what our operating system want? What user want? It should be convenient. That means coming to the goals, there are two types of goals are there.
User hardware.
Okay, various goals are there. We can categorize the goals into two sections. One is the primary. Second one is the secondary goal. So what are the primary goals from user point of view? It should be convenient and
User friendly.
user friendly. Very good. Coming to the operating system point of view, what are the goals? Efficiency. Very good. Efficiency, optimal performance, reliability. Where power is required, energy is required, efficiency is required, boosting up of something is the main goal of the secondary goal from the user not from the user, from the operating system point of view. That means there are various types of goals are there while considering operating system. We can categorize the goals into primary and secondary. Convenience and user friendly, simple, interactive are the type of primary goals. And what about the secondary goals? Efficiency, reliability, throughput, okay, optimization, maximum utilization. Those are the secondary goals of the operating system. Okay. Now coming to the features or functions of operating system. Okay, we'll discuss it. So what are the main functions of operating system? What operating system does actually?
Resource allocation.
The management of the resources. What are the types of resources are there?
CPU.
Memory management. Very good. CPU means process management. Then
Input.
file management. Correct. File management. Then input output resource management. Additionally, maybe security. Security means multiple processes are running. We have to keep some particular space for each of the processes so that they can't create problem to other problem. Okay, and there are various other functionalities are there. So overall, the management part operating system takes care. Okay, how it will take care, we'll see. Okay, and coming to the types of the operating system. There are various types are there, starting from batch operating system, multi-programming, multitasking, multi-processing, and various other types of operating systems are there. Can you tell any one or two additional operating system?
Real-time operating.
Real-time operating system, very good. And
Embedded operating.
embedded operating system, very good. Okay, so first we will discuss few important questions. What is batch operating system? What is batch operating system? So earlier time, number of processes are very low, and the resource for executing that process is also very low. So what people have decided, okay, there are multiple programs are there. We will make some group and then we will allocate to CPU. This process is called the batch operating system. So in ancient time, batch operating system is quite popular. Here the important points to remember is processes will come. For example, P1 is utilizing CPU. That means it uses the CPU for its I/O as well as for execution. It combines both. Okay. During the execution, no other process will enter. So this is the concept of batch operating system. That means first P1 will come. It will complete its execution. Then P2 will come. It will complete its execution, and finally P3 will come, and various other processes will come. Okay, this is nothing but the strategy of batch operating system. Coming to the multi-programming. So what are the advantages and the disadvantages of batch operating system? This is very easy, simple, but management of the resources are complex. Utilization of CPU is very low because at a time we are processing only one device. Correct? So there are various other drawbacks are there. Okay. Now coming to the multi-programming. What we are telling, CPU, you don't do it for somebody. If some student don't want to come to the class, we will bring some other student in place of him. Or maybe if he is busy, he is looking into some other opportunities. In place of him, we will bring some other person. When he will come, we will look into that concept later. That means multiple, for example, processes are generally stored in the secondary memory. Correct? We fetch processes in the main memory. For example, 3 process P1, P2 and P3 is present in the main memory. So what our CPU will do? It will take one from this pool, send here. This is the execution. After that, it will terminate. Correct? One process will enter into the CPU, it will get terminated. But in between, if that process goes for IO or for some other function, or that process goes to in halting state or in some other state, in that case, what our CPU will do? It will collect another process from the main memory and it will start executing this P. That means CPU will not be idle for a long amount of time. Maybe during swapping of 2 programs, it may be idle, but the utilization of the resources will be high. So the main concept is so many processes will be there in our main memory. We'll pick one process and we'll allocate that process to CPU. It will go for execution. If that process goes to some other state or goes for IO or goes in other state, in that case we will collect another program or another process from the main memory and we will start executing. So here one point comes, what are the differences between program versus process? What is program and what is process?
Program is set of instructions.
Program is set of
Instructions.
okay, and
Process is program in execution.
in execution. That means where program will stay and where processes will stay.
Program will stay in secondary memory.
Normally, programs we keep in the secondary memory. That means one file is there, maybe that can be executable, non-executable. Set of instructions are there, set of data is there. If that file is present in the secondary memory, we can call that one as program or process. Program. For example, this program is present in the main memory. Then can we call this one as process?
No.
Can we call this one as process?
No.
No,
Only
because it is not in the execution mode. For example, alarm. We set alarm for 7 o'clock. It is program or process?
program.
It is a program, right? We set for that period of time. That means this program is ready for execution, but it is not allocated CPU. That means it is waiting for the execution. So this is clear what is the difference between program and process. Okay. Now coming to the multitasking. So in this place, one problem is the occurrence of the problem is very high. This problem is called the starvation problem. Processors has to wait for long duration of time. Waiting time is very high and the turnaround time is very high. Okay. So what is waiting time and what is turnaround time? For example, process PI entered into the CPU, for example, at time t0. Okay. After that, it got CPU at a time tk, and it completes its execution. For example, termination at t min. So which part can we call the? So what is the turnaround time and the waiting time?
TK minus T0 waiting.
What is the waiting time?
TK minus
Tk minus T0. When this process is first time called for CPU, is called the waiting time. Okay, and the enable to completion time is called the turnaround time. So we want minimum waiting time, minimum turnaround time. So these are the problem with the multi-programming. So what we are telling, okay, there are some problems are there. We can't improve the capacity of the processing, but we can schedule. We can allocate each process maybe for some q amount of time. This time is called as the time quantum. So processes will come, various processes are there, P1, P2, for example up to Pk. We will allocate each process maybe for 2 instances of time. They will enter into the CPU, they will execute for 2 instances of time, and again they will come into the queue. Similarly, this is true for second process. They will come, they will go for execution, they will complete. In this way, we can reduce the waiting time. Can you reduce the turnaround time? Can you reduce the turnaround time? Still, turnaround time is high. That is a problem. Here, the interactiveness, how fastly we can switch the processes is the main concern. So that user can feel that okay, he is working for me only. Batch processing, multi-programming and multitasking. These are parallel execution process.
No.
It provides the parallel execution?
No.
No. Correct? So, what do we want?
Multiprocessing.
We want multiple cores or multiple CPU in one system. We don't want more resources. We don't want more memory. So many processes are there in today's world. Their memory requirement is very low, but they want to process as fast as possible. That means we need multiple cores, multiple CPU in a single hardware. So that multiple execution in single hardware, multiple CPUs are there, and using this we can process various programs. So this concept is called multiprocessing. This is the actual execution, parallel execution. Now point comes, what are the differences between multiprogramming and multiprocessing? What are the differences between multitasking and multiprocessing?
Single
Single
program
core
multi.
and multiple cores.
Single core, multiple core. Okay, very good. What about execution? Single process execution based system. And multiprocessing?
It's faster.
Okay. What are the disadvantages?
Multiprocessing.
Huh?
More turnaround time.
Turnaround time?
More for
More.
multitasking.
Okay. And what are the limitations? Major limitation.
Waiting.
Waiting time. That means one point you are missing.
Single.
High priority process has to follow this instruction. Even PM comes, he has to follow the traffic. Even ambulance comes, it has to follow the traffic. This is the major problem with the multitasking. There are some emergency processes are there, right?
Yes, sir.
Emergency processes are there. We have to execute them as fast as possible. In that case, multitasking system fails. So what we want? Multiprocessing based system. We want multiple CPU in single hardware. We don't want multiple hardware. If there are multiple hardwares or multiple computers are there, then the utilization is a problem, management is a problem, cost is a problem. Even wastage of memory will be a problem. Right? In our today's computer or in laptop, even in mobile phone also, dual core, core 2 duo, i3, i5, i7, now Ryzen also came, right?
Yes, sir.
Architecture is completely different. Multi-core processor. All are multi-core processor. Correct? So these are the points for multi-programming and multiprocessing. So another important point is there. While managing all these resources and all the processes, our operating system sometimes incurs or faces one problem. Can you tell what is that? During the management, while managing all the resources, all the processes or all the devices connected with the operating system, it faces some severe problem. What is this? Means what we can call that problem?
Same. Multiple process seeking to same information resource.
Okay. Then what will happen? If they ask for
One process trying to access the resource
Another
Ah,
process
which is held by another process.
then what will happen?
Deadlock.
Very good. Problem is deadlock. And its small brother is called Younger brother is called the it's younger brother. Deadlock is the last stage. Before deadlock,
Race continue.
Starvation.
Critical system.
starvation. Very good. Not the critical section. Starvation. Okay. Multiple processes are there. They are waiting for large amount of time. We can call this stage as the starvation, right? Correct. If multiple programs, multiple processes, they completely stuck. That means the
Deadlock.
deadlock. So deadlock is like, for example, some process is there, P1, P2. For example, two processes is there, and the two resources, R1 and R2. Okay. So, for example, P1 is holding these resources R1, but it also one R2. We can reverse it here for better understanding. Similarly, for example, P2 is holding this one, and it also wants R1. That means all are waiting for some other process. It is holding something and it is asking for some other resource, which is held by some other processes. So this type of situation is called the deadlock.
Deadlock.
Deadlock means definitely there will be a cycle loop. If loop is there deadlock?
No, we can't.
May or may be,
May or may not.
depending on the type of structure. In case of single instance graph, definitely there will be deadlock, right? Single instance, R1 has one instance of resource can provide. In this scenario, if some loop is there, that means
Deadlock.
definitely deadlock. If multi-instance resources are there,
We have
for example, I have 10 hands. If there is any loop, then you can't tell, right? I have multiple hands. But if I have only one hand, then it's very difficult. Okay, so this situation is called the deadlock. Okay, and coming to the other points, important points. Coming to the another point. Operating system modes. What are the modes are there? What are the modes are there in our operating system?
User mode and kernel.
User mode and kernel mode. Very good. That is user mode and kernel mode. What is user mode and kernel mode? When a program is in execution state and users are taking input, giving some instructions, in that stage it don't want other resources. That is called the user mode. And kernel mode means when the operating system manages the resources, including the programs, including the processes. That is called the kernel mode. So while we can see the connection or what are the logical connections between the user mode and kernel mode. For example, one program is there, P1. It is in the execution mode. We are assuming that the program in the execution mode. It requires some file or some other module which is managed by the operating system, not managed by the user. Okay, managed by the operating system. In that case, it will send one request to the operating system about the services. What our operating system will do? It will first rectify whether that services can be given to that program or that process. After that, our kernel will do some function. Once the process or the functionalities of the kernel is complete, it will again give access to the user or the program. That means when a program is in execution mode, it is in user mode. When program needs specific services or specific module or specific unit or some memory, extra memory unit, it has to request to the operating system, and the mode will change from user mode to kernel mode. Here kernel will comes into the picture. It will first check, first identify, it will rectify the points, and then if possible it will provide the access. Again the control will go from kernel mode to user mode. Up to this much is correct. This much is fine. So what are the points we have studied today? What is operating system? What are the features of or functions of operating system?
Goals of
Then
Goals.
what are the goals of operating system? Very good. And then
types of
what are the types of operating system? And
OS modes, kernel and user mode.
what are the types of standard modes are there in the operating system? Okay. Can anyone tell the example of real-time operating system?
Missile tracking.
Missile taking. Very good.
Robots.
That is correct.
Robots.
Robot. Okay. Fine. Any other thing? Air traffic controller. We need to track all the flights real time. Otherwise, some memes are there, right? 45 degree. If flight comes in 45 degree, another one goes 35 degree. So many memes are there.
Yes.
Power of physics, right? So motivation for JE or something is there, right? So this type of application, for example, in car also, safety belts are there.
Autonomous vehicles.
If our car does something, car has to immediately react and open the safety belt. If it don't happen, then injuries may be possible. If it opens after 1 minute, then it will again push you back. That is also a problem. Okay, and now coming to the examples of operating system. What are the types of examples of operating systems? Can you tell any one or two?
Windows, Ubuntu.
Linux.
Ubuntu.
Windows.
Ubuntu is a type of Linux, right?
Yes.
Yes.
Okay, and
Windows.
Windows. Now the latest version of Windows is
11.
11, correct? And
Mac
any
OS.
other
Mac.
operating system?
Mac.
Mac OS.
Mac OS. And I think from Chrome also one is there,
Chrome
right?
OS. Yes, sir.
Chrome something is there.
Chrome OS.
Okay. So this is fine. But the last point. Okay. Last important. When our operating system starts, or specifically when computer starts, what will happen? How our computer starts? We have discussed about operating system so many things. But what is the basics? First initial stage, how operating system starts.
OS.
Not operating system, how computer starts.
OS loads.
Like
as
when the power is on,
When the power is on, first step is to
turn
we have to
on.
turn on the power. You can correlate with the Iron Man actually. This is not the Iron Man, but you can think of this is some Iron Man. Okay. Fine. This is Iron Man. You can correlate the starting of the computer using the Iron Man. So what is the first step? You have to wear the Iron Man jacket. What is that one called? Armor?
Armor.
Armor, right?
Yes.
Something is there.
Mark.
Good. So Iron Man is our role model in our childhood times. When Iron Man comes, we have to see that one. We can't miss actually. Okay. So first thing is we have to turn on the
Power.
computer, and here we have to wear the jacket. Second step in Iron Man. What is the second step? What it will do? This armor jacket.
AI will get loaded into the system.
AI will load it into the system. Any other suggestion or any other viewpoint? What this jacket will do? First, it will identify all the components are working properly or not. It will check.
Yes, sir.
Self-checking system is there.
Yes, sir. BIOS.
Similarly, in our computer also, one small module is there. That one is called
BIOS.
BIOS system. What BIOS will do? It will identify all the components, whether those are connected or properly it is functioning or not. Correct. After that, what Iron Man will do? Our that Jarvis, the main controller, Jarvis will come out. It will check the available battery capacity
software like
and
resources.
how far it can fly, and the other important components. Similarly, in our operating, in our computer, one module is there. This one is called bootloader. Correct? Bootloader. What bootloader will do? It will check all the memory components, whether primary memory, secondary memory, the essential memory components are working properly or not. Okay. Now our both computer and Iron Man both are ready. Finally, what we have to do?
Load the OS into main memory.
That means which module will come? Which module will come for
Bootloader.
loading?
Bootloader.
Bootloader means master bootloader, right? One master bootloader is there. Master bootloader is there.
Yes, sir.
It will fetch the operating system. Maybe there are two types of operating systems are there. One is Linux, one is Windows. So what it will do? It will identify the user input. Based on user input or based on some timer, it will identify the operating system. Similarly, here it's our decision whether with this suit we can walk or we can fly. It's up to us, right? And finally, all these things will go in a protected mode. And finally, our operating system will start. At the back end, it will start all the services, and finally, it will give one platform to the user. Okay, so this is clear how our computer starts. So once computer starts, our operating system will come, and these are the functionalities of operating system. Okay, so fine.